Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge O Levels Physics 5054. Today we have selected a paper 2, and in this video we are going to attempt a single question from that paper 2. The paper selected is May-June 2023 2 paper. This paper 2 belongs from the zone 2, and we are going to attempt question number 5 of this paper. This question is related with the new topic which is added into the Cambridge syllabus, that is diffraction of the waves. And here in this question, we are going to talk about the diffraction of the of the the water waves. So before let's start this question, and here we go. So you will have this question. Let me show you. Okay. So here we have that question. It says question number 5 of that paper. So it says water waves are transverse waves. Underline 2 other examples of the transverse waves. Remember, this is very simple, straightforward. The 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 S waves, they are transverse waves, and the X rays, they are also transverse waves. X rays are part of the electromagnetic spectrum. They all are transverse waves, and in the seismic waves, the P waves are longitudinal and the S waves are transverse wave. It's a fact. Please remember this. So S waves and the X rays, underline them. These are your. So here we have the marking scheme, and you can see question number 5 showing up on your screen. So in the question number 5, this is the answer. So hopefully you understand this. Okay, now he says figure 5.1 shows a wooden bar and a glass block in a ripple tank. The depth of the water in the tank is less than the height of the glass block. So what will happen? Here we have a wooden bar which will be producing the wavefronts. So these wavefronts are basically shown in the question. This wave, and these wavefronts we have to draw. The wooden bar moves up and down once every 0.1 second to create the crust. The speed of the water wave is 27 centimeter per second. Calculate the frequency and the wavelength of the wave. The frequency is the reciprocal of the time period. The time period here is 0.15 second. So we have to find out its frequency. You know, the frequency is equals to 1 by t, and you just have to reciprocate that time period, and you will get the frequency. And when you use this formula, remember the time must be in seconds. It is in seconds, okay, so it's good to go. So 1 divided by 0.15 second, that will be 6.67 hertz. So that's the frequency. And then we will find out the wavelength, and the speed is given, that's 27 centimeter per second. The frequency is given, that is 6.67 hertz, and the wavelength is question. So I'm going to use the wave equation. V is equals to F lambda. So lambda will be V by F. So V is 27 centimeter per second, and the frequency is hertz. So whatever is the unit used for the length in the speed, the same unit will be for the wavelength. So because in the speed, they have given 27 centimeter per second, so centimeter is used. So the wavelength will be automatically in centimeter. So lambda is equals to 27 centimeter per second divided by 6.67 hertz. So the lambda will be 4.079, 4.0 hertz. So my answer is 6.67 hertz and 4 centimeter. So let's check the answer. So our answers are right. Hopefully you understand this. Okay. Then the question number 5, it's a part, is second portion. The wave diffracts at the right hand edge of the glass block. On the figure 5.1, draw 2 crusts after they pass the glass block to show the diffraction. It's a 2 marks question, and this is the main question which we want to show you, because this upper portion of these wavefronts, that will remain straight, But because of this edge of this barrier, what will happen? They will diffract. So what will happen here? I have drawn quadrants. This is basic thing which I wanted to show you, that we have drawn quadrants, and let me show you how I have drawn quadrants. You see, if you look at this diagram, you can see that I have taken my compass. I have opened this compass equals to the wavelength. I put the needle of the compass at this edge of this barrier, and I have drawn here the quadrants. Then I opened my compass equals to 2 wavelengths, and then I have drawn this quadrant. Then I opened my compass 3 equals to 3 wavelengths, put my needle of the compass on this at the end of this barrier at this point, and then I have drawn this one also. So finally, the shape I got is this one. So this is the shape which I got, and let me show you. This is finally you will get these shapes. So these are the quadrants, and here it remains straight. The wavelength has not changed. And let me show you the marking scheme. It says straight wavefronts above the block to the right with the same wavelength and correct diffraction. Wavefronts, quarter circles with the center at the top corner. So hopefully you understand this is the basic thing for which I am making this video. I just wanted to show you this technique, that how I have drawn these. So this you can see, and look at this diagram. They are very, very important. You see, this is how I have drawn this. This is how I have drawn this. Okay. The second part, then the third part, he said, describe how a wave with a smaller wavelength is made with the wooden bar by increasing the frequency of the movement of the wooden bar. If you will increase the frequency, the waves produced will have less wave length. Okay, so then he said, describe how decrease in the wave affects the diffraction. So when the wavelength will decrease, so the gap will still be the same. So if the wavelength is shorter than that gap, then what happens? There will be less diffraction. So these are my answers. So let's have a look at the marking scheme. And he says, increase frequency of the movement of the wooden bar and less diffraction or less bending. So these are the two answers. So we are done with the question number, you can say question number 5. So my dear students, if you find this video useful, interesting, and it's beneficial for you, please like this video, please subscribe to my channel. Also, please share the link of this video on your Facebook accounts, on your WhatsApp groups, on your Twitter, on your Instagram, on your Snapchat, wherever possible. Because when you do this, you helps me to promote my channel. So thank you very much. Have a good day, and God bless you all.